now we are here. Now I want to give you a short introduction about what we are going to speak about. We will increase our knowledge about Ethereum and look into the magic of smart contracts. In addition to that, Kai Christian Wagner from Eurocom is here. He will speak about self-sovereign identities. And why it's so important that we speak about identities is because a self-sovereign digital identity can replace any key and any password you have in the future. It will be the digital yourself identity you own and you can own, but only if it's a self-sovereign identity. There's a differentiation between self-sovereign and not sovereign identities, so most time they are managed by others. But to break this up, to make it possible that we can own our data and that our digital self is not abused and exploited anymore, we need to own that identity. So this is what it's about. It will be the key for a lot of technologies to follow because all of them need some way of authentication and you need to have some way of storing your keys about it. So this is digital identities. Let's get started. The very basics, just 3 slides about the very basics. Oh, actually 4 slides. It's really important to understand the private-public key encryption scheme. You don't need to know everything about it. It's enough if you understand the concept. You have a private key, whose secret. You never show it to somebody, you just keep it. It's usually encrypted on your machine or on your mobile phone, and you use it to sign transactions. So if you want to send somebody money on a blockchain, you have that secret key which gives some kind of signature, like if you make a stamp on the transaction, which is unique only from you. But everyone in the world can check it with your public key. This is a key which you can easily share. It's often connected to your address to receive like payments, and the blockchain itself will take care that everyone is knowing about it. So this is also oversimplified, but I want to make clear, this is what represents your ownership about crypto funds, and this is what represents ownership about digital assets. So don't lose it, store it, so that you can recover it, and it means also that you take responsibility. Because if you think about a bank, if you lose your bank card, you go to the bank and say, oh, I lost my bank card, can you please send me a new one? You pay 10 euros, you get a new one. If you lose your private key, you're done. It's away. All your money is away. Your identity might be away. There might be some ways to help you to recover it. But be careful. This means you take responsibility for owning what you own. Let's speak about hash functions. A basic thing, but every time when I explain it, it's like a little bit magic. It is a one-way function, a mathematical one-way function. This means that you can use any input you want to use. You can use a word, you can use a picture, you can use a data file. You can use anything what is computational and make a hash out of it. The hash will always be the same size. And it will be, it looks like this. You can imagine it like a color. You can mix up a color, but you don't know which colors you actually use to mix it up when you see the result. You can guess it, but you can have a lot of variations producing the same outcome in this case, but you cannot tell what was the original one. Okay, but in this case, just to keep that in mind, it's a little bit like color mixing if you have a hash and a second hash, and you hash them together. So another picture there, unique digital fingerprints. If I take my thumb, I make color on it, and I put it on a paper. What can you tell about me if you haven't seen me doing it? Can you say how old I am? Can you say which gender I am? Can you say where I'm coming from? You can't. It's just a fingerprint. But you can prove, if I'm standing next to you and showing my finger, that I'm the person who is connected to that fingerprint, who is unique. This is an oversimplification again, but it shows what mathematical one-way function and digital fingerprints can do. They can connect two things without letting you know everything about what's behind it. So let's do some magic over here. So it's about the Merkle color theory. It's actually not real, it's fictional, but it's about Merkle trees. That's the structure which is in blockchains, which represents the immutability, where you can check that nothing has been tampered with. So look at these things here. These are, every dot here is a hash of a transaction. So it is a digital fingerprint. And if you mix them, like color mixing, then you get new colors. And if you do that further, like taking two fingerprints, producing a new fingerprint, then you get something that's called the root hash. Every block of transactions, called block in the blockchain, has this root hash. And with that root hash, you can tell that every transaction is valid in there, because they're all interconnected through that color mixing process, hashing the hashes. And if you change only one transaction, and those trees are identical, but this one is different. If you change one color, it will change the mixed up color, and it will change the root. This is how you can differentiate if a block is valid or not. Because it's really easy to check, and with the slightest change in the transaction, it will result to a total different result. And every block having the previous block header included, like the fingerprint of the block before, and over again they are chained together, you can validate every transaction back to the beginning. So that's how the blockchain is growing. We have a block, we get a root hash, we get new transactions in, we have a new state, taking the old hash, hashing it with the new result, getting a new block with a new hash, hashing it together. Ethereum puts a computer on it. So every node in Bitcoin is pretty much a stupid calculator, like doing calculations. Actually, I think some people say that Bitcoin is a protocol like from the 80s. I think it is a highly secure, slow protocol, which is really secure. And that's like the important thing. It's a digital gold, so gold is hard to move. Bitcoin does not need to be fast. Bitcoin does not need to do calculations like Ethereum. Ethereum is optimized for computation. Bitcoin is not. So it's a totally different role. They are not in a competition here. If you put money on the blockchain, you better trust Bitcoin. It's much, much more secure protocol. If we think about Ethereum, that's a protocol where we can put on applications. So that's like a decentralized computing system. One thing here, every transaction in Ethereum is metered with gas. Gas is something which is calculated through a specific formula. What you pay then in Ether. The gas price is what you need to pay to participate. And it is a protection algorithm. It ensures that nobody does like scam for free. Because if you pump something into the network, you will pay for it, always. It's a good protection algorithm. Gavin Wood was the guy who joined like Vitalik in 2014 as well. And he wrote the specification on the EVM. So here you see like in the EVM specification, you can look it up, it's not secret, it's like the public EVM specification for Gavin Woods, where you see all the prices you pay standard for a smart contract. Just to give you a slight understanding, if you want to upload a 10 megabyte picture, it will cost like hundreds of thousands of US dollars or euros. So you are not really, probably not have the money to do that. But that's not what Ethereum is for. It's for computational steps. It's for logic. Logic can be put into programming code with really a small amount of data. And there's another infrastructure which is called Swarm or IPFS, the Interplanetary File System, which provides a decentralized, say, storage layer. Ethereum does the computation for it. So the block structure itself, we are not going deeply into that. I just want to show you here that it is pretty similar to Bitcoin. There are some changes which are not the same, like the uncles. So in Bitcoin, when you have a fork and you are not winning the race condition, you get nothing. But in Ethereum, it is the case if you do a fork not by mistake, finding the puzzle result at the same time, like other miner, you will get a reward for the uncle. This is just some technical details for the technical guys in the audience. We have also the difficulty, like proof of work. This will change with the proof of stake, like I said before. And you have, as a new parameter, the gas price used. You have also pretty similar address where you send from, where you send it to. It's a pseudonymous system, which means that you can generate millions of addresses without the fear that you get the same address twice. And you have the opportunity to use this address as a sender address or as a receiving address in the system. Every transaction itself is totally public and transparent. So there is something called Etherscan, where you can just check out all the transactions happening on the blockchain. If you want to ensure that you're staying anonymous on the blockchain, you need to ensure that this connection is never going to show up. What is your address and what is your name? Because from that point on, you're traceable, and you can trace it down to which funds you send to whom and all the other stuff. Some people say 1/6 of all transactions in the Bitcoin network are de-anonymized already. So this is a public ledger system which has anonymity-wise not really good functions, but that was not what it was intended for. So we have the gas price, the gas limit, the value which was sent in Ether, or you can send data. And this is something which is different to Bitcoin as well, because you can send program code or you can send a message. And you have the signature. The signature is coming from the private key again, representing your ownership and your authority. Does anyone know who this guy is?
The ultimate computer from Hitchhiker's Guide to the Galaxy.
Yeah, he said like the ultimate computer from the Hitchhiker of the Galaxy. True. Deep thought. Right? What was deep thought? A really slow computer?
Yeah, that had
finding the answer
for
all the questions, yeah. Which was after 7.5 million years.
42.
42. It's a nice story, but there are actually some things which are pretty the same way in Ethereum and with deep thought. It's not 7.5 million years, but the Ethereum network is really, really slow. It's much faster than other blockchains, but it's still really slow. If you think about 10 transactions, 15 transactions, they even reach a little bit over 1 million transactions per day sometimes. But when you compare it with Visa, 15,000 transactions per second, if you compare it with Twitter, millions of transactions per second, that's slow. That's really slow. We will see some changes in that field, but this is the major problem we are facing in the blockchain technology. We all want to vote on something like Ethereum, like millions of people at the same time. 10 transactions per second, wow, we're gonna wait a long time to see the result. CryptoKitties, some CryptoKitties are like back there, small little kitties. They really did some congestion on the network. And this was a small application. So we will need a way how we can solve that problem. And there are different opportunities how we can solve it, but the sharding is one I want to give you a small picture about what it is. So you have that default computer, that big one, that really slow one. What you do now is you create a smart contract. It's with an input, a logic, and output in a like trusted, permissioned ledger. And what you do is you connect new computers to it. Another deep fault in another universe, and another deep fault in another universe, until you have hundreds of these computers being connected by the validator manager contract to the main chain. This might give us more scalability. We will see that process in this year, but there are problems as well. The RAID network is another approach to ensure scalability and privacy. But this is going too far for this evening to explain this. And we are going to see which solution will make the run. Let us go back to, I think, the point where the paradigm shift is happening, the smart contracts. Smart contract is nothing else than a digital contract on the blockchain. Okay, where you can write in, like I said, can put in an input, and then with the logic something is happening, and then you get output. That's the reason why people say code is law. Actually, if this is true, depends on the definition of law. If you're in a country like Germany, the law is defined by the power who has the right to do the law, to set the law in power. In the blockchain, it's a little bit different. If you define something, it will just happen the way how you define it. Or you try that it will happen the way how you intended it. Because there's a big difference between having something running how intended and having something running differently through a bug. So there are a lot of smart contracts out there. We have seen millions and millions of losses in money-wise because of bugs in software. We have, for example, had a parity hack with the Multisignature wallet of parity, where some foreign person sent a destroy command to a smart contract where they fucked it up and put the destruction function in a global part where everyone can call it. And that's like a big problem. So it's really, really hard. It's really easy to write a smart contract, but really, really hard to write it in a way that it will work as intended. So code is law might be if you can't stop the blockchain, if it's not able to be censored, then you don't have the opportunity to influence what is happening on there. And then indeed, it might just happen as it was described, with its benefit and with its downside. Let's have a look on basic smart contract logic. We have two kinds of user accounts. You have the outside lying user accounts, which are the user accounts from me and from you, which are from normal users. And you have the smart contracts itself. They're in the blockchain. And think about that circle as the state of the blockchain. What I said is Ethereum is a really slow system. And the reason why it's a really slow system is because every calculation is happening on every node. So if you run an application there, it will be run in parallel like multiple hundred or thousand times. And every node is confirming the result of the calculation, sharing that with the others, being able to confirm on the consensus they agreed on that this is the correct state. The blue area, that's the state. And if you want to make a transaction to another user account, you can do that. If you want to make a transaction to a smart contract, you can do that. And if the smart contract holds code, it will be run. So it depends a bit. You can put money on it, but you can execute the contract as well. And there are some other things possible with that combination. You can do really complex things there. Like think about Lego. You have that Lego piece, and you can put different Lego stones on each other. And some of the Lego components have special features, like being a door or whatever. You can build interesting things with Lego Electric, or how is it called? Like that. You can build, every stone has its function, and you can combine them. And when you take smart contracts, you can chain them together. They will be public. So this means everyone can call the smart contract. And you can use them as building stones and interconnect them with each other to produce like a more complex logic. To give an example for this, you probably all know Kickstarter. Kickstarter is a platform where you pay the platform to support a project. And you trust the platform that when they reach the goal, they will take the money and give it to the project team minus some fees. And the project team, which tries to develop that product, They trust the platform that they get the money. And something like this is pretty possible to do with a smart contract. So you have the product team, and you have all the different people wanting to support that project. Now they send funds to that smart contract, which might have, even that limit we spoke about for like Kickstarter. If the limit is reached, the funds will go to the product team. If the limit is not reached, it will go back to the owners. This would be a nice way of ICOs. Actually, the first round of ICOs with the ERC20 token standard did not went this way. Just to give you one example there are like many other examples. For example, turn that way around. You have somebody who is owner of a company, and he has a lot of employees up there, and he wants to pay them every month. So what he does is he defines the percentages of the revenue which will be paid in paychecks every month in that smart contract. It's transparent, everyone can see it. And if he sends the money to the smart contract, everyone will be paid accordingly. So you see that there is a business logic which can be used. But there is much more things are possible there. Let's speak for a second about that. The most cryptocurrencies you see today are actually cryptocurrencies based, like in the top 100, based on the ERC20 token standard. The ERC20 token standard is a smart contract, which tells you, well, actually produce that amount of tokens with that name. And they have a specific event ID, so you can trace them, and then you can sell them. You can produce your own currency in 5 minutes with the blockchain, with the Ethereum blockchain. And this did happen. There's a lot more to it to actually give a token value. But most of those ICOs we have seen will be not existing in 10 years. A lot of them are scams, and a lot of them did like things which are unbelievably stupid. But still, people put money in there with the faith of the speculation that they will get rich fast. So we have some examples of tokens which are based on the ERC20 standard, which are indeed, I think, valid token models and indeed a good approach. We will not go into that because of the time. The ICO itself is something like you get that amount of tokens in exchange to some ether you send to us. It is possible to do that in a smart contract with an exchange ratio you define in there. Another possibility what you can do. We spoke about the parity hack for a second. You can have the situation that multiple people need to agree on a transaction before it is done. Think, for example, about a family fund. 10 people pay in for like urgent situations. And they need to agree, like 6 of 10 people or 7 of 10 people need to agree that this money is going to be used, like to send out to an address if somebody wants to withdraw money. This is a logic which is quite possible with multi-signature wallets. You can define like the consensus, which like the quote of 7 to 10, which need to agree, and then the money will be confirmed and sent out if somebody wants to withdraw money. And this is possible without cheating, because everyone is in its is its own owner of the private key, and as long as there is no other things ongoing, like somebody is coming and saying, if you don't do that, it will be fine. Okay, so this is a quite interesting structure. But you can do a lot of more things with it, and we are just scratching the surface. Something what was really, really interesting, this is from Slockit, and Christoph Jensch, who is like the ex-CTO, now CEO of Slockit, he was the person who wrote the white paper for the so-called DAO, the Decentralized Autonomous Organization. An organization without one leader, an organization without one owner. It is practically a pretty democratic structure, and it was used really, really heavily after it was published to gather funds for different projects. The problem with it is, like I said before, it's really easy to write a smart contract, but it's really hard to write it as that it is will do as intended. So something bad happened with the DAO. And some people used their opportunity to attack it and withdraw money. Like I said before, the blockchain is immutable. So if something like this is happening, you cannot reverse the transaction. But what happens? Anyone knows? Hard fork. So this means the majority of the community decided, of the miners, I need to say that, decided that they will reverse that transaction. They did a so-called state transition, changing it back that everyone got its money back. And in that kind of reality, so we had a split of reality, it's called a fork. Can go two directions with the software in open source. And what happened is today we have Ethereum Classic. They own the old reality where the hack happened and was successful. And Ethereum, where there's the other reality where the hack was reversed through a state transition. Everything else stayed the same, but the hack was reversed. And the people got their money back. So you see that's a big problem to write things like I said, that they are act as intended. How to create a smart contract? It's pretty easy. You send out a transaction without something in the to field, and the data will be published as an executable. So you can create that smart contract pretty easily. After doing that, you have only one thing what you still can do next to using it, what everyone can do. You can destroy that smart contract. With the owner of the private key, you are able to do that. So if you develop applications for smart contracts or application based on smart contracts, be it decentralized applications, it's really important to think about the structure, how you need to code it. You have that building blocks which are on its own really optimized to cost low fees, so it's attractive to use them. In addition to that, so they are really, really secure. Let's look a little bit to another use case, which is a real-world use case. Etherscan is the first decentralized insurance on the blockchain. And what they do today is they have insurance online for delayed flights. So if you hop on a flight, you can use Etherscan to ensure that if your flight is delayed, you get money. It's nice. It's not a big thing, they don't make gambling out of it, so there's a maximum amount of fees. But the difference between gambling and insurance and not gambling, there was a nice guy who did a good presentation in the TU about it. It's actually only the agreement that this is an insurance, okay? So it's really interesting. So you have something I want to introduce you here. The blockchain itself is a digital thing, it's a digital world. So how you connect now this analog world to that digital world? The way how you do it is through so-called oracles. The only people who can know what is happening are the people, us, and oracles, which are sensors which measure the outside world and draw this data into the blockchain to make decisions. If we have flights, it's really easy to figure out if a flight was delayed. Because we have multiple sources which are trustworthy, like the International Flight Observation, different stations, and they all tell you if the flight was delayed or not. So it's really easy to get that data through an oracle. And that's like the challenge. We need to ensure that the oracle is saying the correct thing. So you can combine it with like human feedback. You ask 1,000 people, out of 1,000 people, 13 people randomly, did this and this event happen? And out of these 13 people, you, for example, give only 7 the opportunity to gain a reward. So they need to answer fast to ensure that they are not speaking to each other and make a story up. So something like this. You need to set incentives. That's also about blockchain. You always need to set incentives and gamifications to have people participate. In Ethereum and in Bitcoin, it is that miners get a reward for participating in the system. That was the reason why a lot of people joined in the beginning, in addition to the great opportunities.
Hero is introducing reward-based peer-to-peer betting on the blockchain. The odds in current systems are always in favor of the betting providers and bookmakers, making conditions unfair for the player. Social dynamics are lost as interfering middlemen prevent direct peer-to-peer interactions. Most centralized systems are non-transparent, so it's difficult to follow what's going on behind the scenes, making it impossible to know who you are dealing with. All of those issues can be traced back to the middleman. What if, instead of one middleman, the whole community takes charge of the money flow and the conditions of a bet? Everyone can join the network, making it possible to create a variety of games. These games can be of any type, limited only by the imagination of the community. Players can bet on the outcome of these games. Winners are rewarded for their correct predictions, leaving a small pot for the Hero Network. A part of this pot enables providers to create more games and enhance the overall gaming experience. Another part is used as a general dividend for all token holders. Hero's economy is built to expand the network, creating a huge variety of new games and organic growth of the Hero community. Putting the community first, as well as making betting transparent and enjoyable again, is Hero's mission. Join today and grow with us.
So what we see here is that they eliminate the middleman. The middleman was in a traditional betting infrastructure, a betting company, which you need to trust. And now we take the logic which is embedded in that company and put it on smart contracts and enable to build platforms and economies around that logic, eliminating the middleman. And this is true for like all industries where you have a middleman. It's true for lawyers, it's true for notaries, it's true for title registries. For all the things, it's true that it's possible to eliminate a middleman. But we are far away from having it everywhere right now. But we are going to start right now. Like with companies like Hero, they might succeed. They might fail. We will see that. But they have their own token and they create a new industry for themselves. And everyone participating in this industry will be represented with their ownership in that industry with the token, if they do it fair and correctly. Always check if it's really a decentralized infrastructure. Always check if it's politically really decentralized in the end, or if they build something to control it. So we are close to the end of this presentation, and I want to show you at the last thing, that we have like a 15-minute break, that the blockchain itself is actually not one blockchain. It's not Bitcoin, it's not Ethereum. It's like hundreds and hundreds of different approaches how to build blockchains. And we see even new blockchain technologies like successor maybe even, which are for example called hashgraph. Okay, so we see a lot of things happening in the field and it will not go away. We see infrastructure which will empower us to build decentralized applications. And I wanted to show you this slide. So this shows you that there are other platforms which enable smart contracts as well. Like for example EOS, you might have heard about NEO, Tendermint might do that. There are like Hyperledger from IBM. IOTA tries to do that for the IoT world, we will see if they fail or not. But you see that there are different, that there's an ecosystem arising and this will not go away.